Okay, so look at the first equation. We have negative 1/4 y equals 1 minus 3 over 16x. Why is that not in slope-intercept form? Okay, what is with y? The negative 1/4. How do you get that away from the y? No, it's being multiplied, and normally we would divide, but since it's a fraction, I taught you something better. What can you do besides dividing by a fraction? Right, we can multiply this side by the reciprocal, which would be, but don't forget the negative, and then that means we have to multiply this side by that same thing. Okay, now, the reason it cancels over here is because, look, what's a negative 4 times a negative 1? And what's a 1 times a 4? So don't you basically have 4 over 4, which is 1? And do we need to write the 1 beside the y? No. So those cancel each other out. Remember, that's called the multiplicative inverse property. Now when we do it over here, how are you going to multiply this whole thing by negative 4 over 1? Distributive property. So what is negative 4 over 1 times 1? Which is basically just what? I know, but what is negative 4 over 1? Just negative 4, right? And now we have to distribute the negative 4 over 1 times the negative 3 over 16. So you might want to do that in your calculator. Because you're supposed to do that as you come in. Okay, what do you get when you type in negative 4 over 1 times negative 3 over 16? Positive 3 over 4, and then remember that's beside the x. Now let's talk about how the calculator got that. Didn't they just multiply the negative 4 times the negative 3 and get 12? And then 1 times 16 is 16, and doesn't 12 over 16 reduce to 3 over 4? That's how the calculator was able to spit out 3 over 4. Now, to finish this out, shouldn't we just use the commutative property that says that you can add in any order? So we can put the 3/4 x in the front and then the negative 4 last, and now it looks like y equals mx plus b. Okay, so what is your slope of this first equation? Right, because that's the number with the x, that's the number in the m place, and what is your y-intercept? So to graph that, what do we do first? Okay, and then from there to get to our next point? Okay, and can we do that again? No. You can go up 3, but you can't go right 4. So you've done as many points as you can, connect them. We're only doing 2 of these, so just draw your best line. You'll be able to use a ruler for the game. Okay, now look at our second equation. Is our second equation ready to be graphed? No. So we're also going to have to take it to the side, and we're going to have to rearrange it into slope-intercept form. So what do I have to do first? Okay, but look, if I subtract x, won't this side be empty? Right, the 2 needs to move over there, because isn't that 2 our b, our y-intercept? So now we have x minus 2 equals negative 2y. Okay, now what do we need to do? Right, and remember you're dividing the b by negative 2 and your mx by negative 2. So look up at the board so you don't miss that, or this. Isn't that an understood 1 right here? So isn't this like a negative 1/2 x? And then what does that become for your b? Positive 1. Anything divided by itself is 1. And then it equals y. Now, is that normally the way we look at those? No. What property says that we can just... Right. The symmetric property says we can just flip-flop the sides. Now that we've changed that over, what is the solution, or what is the slope of it? And what is the y-intercept? Okay, so how do we graph that line? Right, and then from there? Okay, and then if I do that again, hold on, I went down too many on the first one. Down 1, right 2, and then if I do it again, look what happens. I hit the other line. So now connect those with a straight line, and do you see where they intersect? 4, negative 1. Now, how can we check to know that we have done this exactly right and that that is indeed our solution? Right. You could either plug in this 4 into the x place here and here, and plug -1 into the y place in both of those, or, like Isabella said, it would be easier to use our new rewritten equations, because don't those look a lot easier to plug into than the originals? Okay, so we have y equals 3/4 x minus 4, and we have y equals -1/2 x plus 1. But why did I not write the y's and the x's? Right, what can I plug in for both of the y's? And what can I plug in for both of the x's? Okay, so I want like Joseph's row and towards me to type in the first equation and see if it equals -1, and then all of y'all over, like Chloe and over, y'all do the bottom equation. How do you what? What'd you say? Well, yeah. That's just 12 over 4, which is 3. 3 minus 4 is -1. -4 over 2 is -2. -2 plus 1 is -1. Okay, Brandon, when you typed in 3/4 times 4 minus 4, what did it equal? -1. So that lets us know that that ordered pair worked in the first equation, which was this one, which was originally this one, right? Okay, Lel, what did you get when you typed in -1/2 times 4 plus 1? Yeah. Okay, somebody else. Genesis? Right. So since that point, when plugged into both of our equations, made true statements, that means we did it right and that is our answer. Does that make sense to everybody? See how much work that took? See why I wasn't willing to give you a stamp if you didn't have your work? Okay, you have to show all your work. Rewriting these takes a lot of work, and checking them takes a little bit. Okay, can I erase now? Yes? Okay, number 18. We're doing one more, and then we're going to start the game. No, y'all can figure it out. Just try it tonight. Okay, number 18. Is the top equation ready to graph? No. So 7x equals y minus 3. What's the first thing you would do to get it ready to graph?
Add 3.
Right. We don't want to move the 7x because if we did, the side would be empty, and you can't leave one side empty. So now we have 7x plus 3 equals y because those cancel. Now what should we do? Whoa, whoa, whoa. Doesn't this look... Okay, flip it, which is symmetric. We're done. This is the answer. But to get it in the way we like to see it, y equals mx plus b, you use the symmetric property and just flip-flop the sides. Okay, so now that we've done that, what is the slope of that one? 7/1. Shh, focus. What is the y-intercept? Okay, so what do I do to graph it? And then from there? Okay, why are y'all going down 7 when it's a positive 7? Right. If I tried to go up 7, right 1, I'd be off the graph. So instead, we do the exact opposite. Down 7, left 1. So down 1, 2, 3, 4, 5, 6, 7, left 1. Now, does anybody have any idea why that line is so steep? Well, it is a whole number, but like if it were 3/1, it wouldn't be that steep. What makes... Right, the bigger your number gets, like 7's a large number compared to some we've seen, the steeper the line gets. Okay, is this one ready to graph?
No.
No, so I'm going to take it to my scratch paper, and what do I need to do to get it ready to graph? Right. So now I have 3y equals 3x minus 9, and now what do I do? Right, the y needs to be alone, so I divide by 3. So don't I have y equals x minus 3? So what's the slope of it? Isn't there an understood 1 there? Didn't 3 over 3 become 1? So 1 over 1, and what's your y-intercept? Okay, so I go to negative 3, and then I go up 1 over 1. But if I continue going up 1 over 1, up 1 over 1, am I going to run into that line? So instead, right, down 1, left 1. And now we see them hit. Negative 1, negative 4. Because to get to that intersection, you have to go left 1, down 4. So left 1, down 4. Okay, now remember, you don't have to use your original equations to check them. You can use your new rewritten equations that are normally easier to check with. So y equals 7x plus 3, and y equals 1x minus 3. What gets plugged in the y places? And what gets plugged in the x places? The x? Negative 1 is my x value of my solution. Go ahead and be checking those while I'm getting the game set up.